Welcome to LangChain, a framework that's changed how developers build LLM applications. Let's explore how this codebase brings order to the chaos of working with dozens of model providers. Here's the big idea. LangChain is your universal adapter for language models. Whether you're using OpenAI, Anthropic, or local models through Llama, you get one consistent interface. Invoke, stream, batch. The same methods work everywhere. This is a substantial codebase, nearly 117,000 lines spread across 2,600 files. It's organized as a Python monorepo, with a minimal core layer and independently versioned partner packages for each LLM provider. The repo is actively maintained, with a commit pushed just today. Think of it like a universal power adapter. Different countries have different outlets. American 110 volt, European 230, British 240. But a good adapter gives you the same interface regardless of what you plug into. LangChain does this for LLMs. OpenAI uses REST, Anthropic streams over server-sent events, Llama runs locally. You just call invoke or stream, and it works. Let's look at the architecture. Your application sits at the top. You call high-level functions like init_chat_model to get a configured model, or create_agent to build an autonomous agent. These pull from the core abstractions layer. That's where the universal protocols live. Then we have 15 partner packages implementing those protocols for OpenAI, Anthropic, Llama, vector databases like Chroma. And agents are orchestrated by LangGraph, a state machine runtime. Here's where everything lives. The core sits in libs/core, 62,000 lines defining those universal protocols. The high-level API is in LangChain_version 1, just under 4,000 lines. Then we have the partners directory with 15 separate packages. OpenAI is the largest at almost 12,000 lines because it includes Azure support and extensive model profiles. Anthropic, Llama, Chroma, and 11 others follow the same pattern. Let's see this in code. The init_chat_model function is your entry point. You pass a provider prefix and model name, OpenAI:GPT-4, Anthropic::Claude, Llama::Llama 3. It auto-detects the provider and returns the right chat model instance. Then invoke and stream work identically across all three, even though OpenAI, Anthropic, and Llama have completely different APIs under the hood. Here's how tool calling works in an agent. A user asks where their order is. The agent sends the question to the model along with available tools. The model decides it needs the search tool and returns an AI message with tool calls. The agent executes that tool, gets the result wrapped in a tool message, and sends the full history back to the model. Now the model has context and generates a natural language answer. The agent routes this back to the user. Middleware layers add cross-cutting behaviors without changing your core code. Think of them like airport security checkpoints. Your request passes through retry logic first. If the API fails, it tries again with backoff. Then human approval. For sensitive tools, it asks permission. Then summarization. If the context is too long, it compresses. Finally, it reaches the actual model call. Each layer wraps the next, creating an onion of functionality. Vector stores enable semantic search. Here's the flow. A user asks about transformer attention. First, we embed the query into a vector using OpenAI embeddings. Then we search the Chroma database using cosine similarity to find the 5 most relevant paper chunks. Those chunks become context. We build a prompt combining the query and context, send it to Claude, and get back an answer that cites specific papers. The magic is in that similarity search. It finds conceptually related content even when the exact words don't match. Let's talk dependencies. At the application layer, everything builds on LangChain core for abstractions, Pydantic for type safety, and LangGraph for orchestration. For data, we have ChromaDB and Qdrant for vector storage. Services include the official OpenAI SDK, Anthropic's client, Llama for local models, and Langsmith for tracing. And for development, they use UV as a package manager and PyTest for testing. It's a well-chosen stack that keeps the core lightweight while offering rich integrations. The repo is very much alive. The last commit landed today, literally hours ago. The contributor shown here is a bot that maintains model profiles, which tells us the team uses automation for routine updates. With 3 active branches and ongoing commits, this is a project under active development. The low contributor count in recent months suggests this might be a focused maintenance window or a specific subsystem branch, but the activity signal is definitely green. So that's LangChain, a framework that gives you one interface to rule them all. Write your agent logic once, and switch between OpenAI, Anthropic, local models, or any of 24 providers just by changing a config string. It's the universal adapter that makes building with LLMs less about wrestling APIs and more about solving problems. Thanks for exploring this codebase with us.